Okay, this is the second section in chapter 7, properties of rational exponents. We talked a little bit about what irrational exponents were and how to simplify them. Now, how do we operate with them? The way in which you do so is very similar to what we had done with laws of exponents in previous sections, and we're going to see that evident in this warm-up. So we want to evaluate each expression or the expression referring to each and one individually. And remember that some of these, we can recall. Some of these we can look at multiplying like bases. When you do so, you need to add the exponents. In this case, it's going to be 4 to the 5th or 1024. I'm kind of skipping the step showing these here, each of these being added to each other to come up with this. But nonetheless, that's what we're doing. The next one we're saying, oh, it's 2 to the 2nd to the 3rd, or 2 to the 2nd times 3, 2 to the 6th, which is 64. And then the next one, we talked a little bit about dividing with like bases. We know we're supposed to subtract the exponents, so that's 1 over 3 to the 2nd. Or in that, it also could be written 3 to the negative 2nd, which I guess technically simplified, it looks like this. That's 1 over 3 to the 2nd, which is 1/9. Lastly, 2 times 3 to the 2nd, you multiply what's inside the parentheses first, and then evaluate. We're going to see a little bit of that kind of example here. Much more complicated than this, but this is just 6 to the 2nd, or 36. Okay, so let's look from the beginning here. I do not want you to write this chart. I repeat, do not write. Stop, stop, stop. So look at the recall. We recall from chapter 6 notes, a giant chart of multiplying powers like bases, dividing powers like bases, a whole list of things we've covered. We need to know them. In a nutshell, you need to know all of these and exactly how to use them, because we're going to do them now with rational exponents. Additionally, we look, there's a little note, I want to say the product and quotient properties of radicals still apply, but for the nth root. So now instead of it being the square root of a times b is the square root of a times the square root of b, it's the nth root of that product is equal to each of them individually multiplied by each other. So you have that option as well, and then the same thing for the quotient. So just be aware that that is something you're going to encounter. Now, let's look at simplifying expressions. I have a few examples here we're going to cover. I'll talk about this. There's many, many more for the next part B, but these ones are pretty straightforward. It's just work with laws of exponents, but specifically with rational exponents. Look at the first example. We have 5 to the 1/2 times 5 to the 1/4. In reality, that's the same as saying the square root of 5 times the fourth root of 5. So it's not really something we want to deal with. It's more we want to say, okay, this really could say 5 to the 1/2 plus 1/4. So just like if it said 5 squared times 5 to the 4th, you're taking these two and you're going to add them. Well, when we add fractions, we know in this case, we definitely need to add them. Add the exponents by way of changing the denominator. So if you change the denominator of each, that's 5 to the 2/4 plus 1/4. Or in this case, it's 5 to the 3/4 or 4th root of 5 cubed. Now it looks a little bit bizarre, but in reality, this is nice, but this is definitely better. That's definitely what we want. We want that one for sure. So in other words, that's if I were to ask a little bit further in the simplifying, that's what it would look like. A second example, 3 to the 3rd times 6 to the 3rd, all to the negative 1/3. Now, just to be aware, it's going to look a little tricky. I have more notes for the third example, but this one's going to be a little different how we operate. So if you look, we have the two bases that aren't the same, but to the same power, meaning that previously they had been multiplied by, or they had been raised to that individual power. So we could say, oh, it was 3 times 6 to the 3rd, because that third is the same. This is being distributed to each term, as we talked about in a law previously, raising a power to a power. You multiply them, and that's all still a negative 1/3. So now we want to operate with what's inside the radical, or I'm sorry, inside the exponent, I apologize. So that's 18 to the 3rd to the negative 1/3. Well, there's no point in doing 18 to the 3rd and then end up taking 1 over the cube root of it. That's unnecessary. Let's go ahead and then multiply exponents again, because this right here, this is a power to a power. That is not adding them like we had done in this example. We are now multiplying them. So this is really nice, because that's 3 times negative 1/3. This right here is going to end up being 18 to the negative 1, because they're the 3 and negative 1/3, the opposite reciprocal. So you get 18 to the negative 1, or 1/18. Okay, this example at the 5-minute mark. See what we got. So the last one's very goofy looking, but it's not that challenging, I promise. Same base, something to highlight. Same base here and here. That's 18 to the 1/4 and 9 to the 1/4, all raised to the third power. In raising each of them to the third power, we realize that eventually we're going to have to multiply whatever the exponent inside the parentheses currently is by 3. But for the time being, let's operate. Same procedure as last time. We want to say, okay, and I'm going to make a note there. We want to work backward from raising a quotient to a power. That's the same type of note I had put in the other one. So anything that looks like this, oh gosh, okay. Anything that looks like that. Sorry, I had to get rid of that. That was awful. But anyway, we work backwards from raising a quotient to a power. We're then saying, oh, we can then simplify 18 over 9, which we're about to do, which ends up being 2, to the 1/4, all still to the third power. So now we have to take this 2 right here and then raise it to this power and then raise that to this power. It's a two-step process. In this case, we're going to say, oh, that's 2 to the 1/4 to the third. I just basically took out the parentheses. And then we want to say we want to raise a power to a power, thus multiply the exponents we've been talking about this entire time, being 2 to the 1/4 times 3 over 1, or 2 to the 3/4, which we know we could write that the fourth, let's see how this goes, 4th root of 2 all to the third power. Well, that's the dilemma with writing it in this manner, is the fact that we don't know what the 4th root of 2 is, and there's no point in actually trying to compute that. So we're going to leave it as 2 to the 3/4. So in this case, we've done a few examples. We're going to look at part B here shortly. Make sure you get a chance to jot everything down. Maybe look it over a second time and get ready for that quiz. Okay, thank you. We'll see you in the next one.